Hello guys, today we're gonna start with lecture 3, assembly language programming. And please guys, these first chapters, let's say chapter 1 and 2, if you don't know them, you're not gonna be able to program assembly in massive. There's lots of schools that take it as theoretical part. They don't even do the programming part, but I think that's also worse. If you're not gonna know the programming, why take assembly? You're gonna see how much assembly. Remember what we took in lecture 1. If you had seen lecture 1, assembly will help me what? Most importantly, we can reverse engineer any code, and I can show you an example on that. It's really easy to reverse engineer any code. Think of it. Think of how hard is it if you didn't know assembly. Even if you were a really professional C++ programmer and you don't know assembly, I don't think you can reverse engineer it. And what was another reason? It's gonna improve your C++ a lot. You're gonna go one level lower than C++. You're closer to the hardware. Believe me guys, from my experience, assembly made a big difference in my programming skills, so please know it. C++ and assembly are the two most important classes in computer science. That's my point of view. So please pay attention, and to know programming you need to know the beginning, those, especially chapter 2, and I'll say that again in those lectures. So what did we take in? We took a review about programming languages in lecture 1. We took what assembly is, what a program is. We said why assembly is important. And in lecture 2, we took binary system numbers. And binary number system is what? Base 2. Base 2 means what? We have two numbers, 0 and 1. And what other numbering system we took? Our numbering system. The binary number system is what? For the machine. The machine only understands 0 and 1. And human understands what? Decimal numbers, which is, let's say, 1, 2, 2, 9. 10 is not. 10 is considered 2 digits. So decimal is base 10. Base 10, my range of numbers is from 0 to 9. In binary, my range of numbers is from 0 to 1. Today we're going to take a number system. It's not even in the book, and I like to give it to my students so they know it. It's an old number system. It was used in the IBM, the Macintosh, the old ones, the 4-bit processors, I think, and 8-bit processors. Think of it, 4-bit processor. That was the first computer, and it was used in the really old days as a regular numbering system instead of the decimal. And why they used it is because look at your finger, it's 3 parts. So we're gonna see what, when you look at your finger, why is it related to octal numbering system. 3 parts. Let's see what does that mean. So we're gonna take octal number system, converting binary to octal, converting octal to binary, converting octal to decimal, and converting to decimal to octal. Let's see. Octal is base 8, meaning range of numbers is what? 0 to 7. 0 to 7 meaning what possible 705. Is it an octal number? Yes, it is. What about 802? 802. Is it an octal number? No. Why? Because the 8 is not in the range. I say base 8, but it's not. My range of numbers is 0 to 7. Base 10, remember, decimal is 0 to 9 range of numbers. 10 is 2 digits. 10, 1, 0. So this is not an octal number because of the 8. And now when I say base 8, what do I mean by that? 8 equals 2 to the power 3. That's why I told you the finger is 3 parts. So we're gonna be grouping into threes. Think, when I have base 3, I'm gonna be grouping into threes. Base 8, sorry, base 8. Now we're gonna take another numbering system. You might all heard of it. I gave it in the foundation class. The hexadecimal. Hexadecimal is base 16, meaning the range of my numbers. When I say base 16, is from 0 to 15. That's what I get from this 8, from the 10. From the 8 I get 0 to 7 and 2 to the power 3. From to the 16, base 16, I get 0 to 15 numbers. That's my range of numbers. And we said above 9, what do we have? A, B, C, D. They use characters instead of letters, instead of numbers, because I can't put the 10. 10 is 2 digits. We need 1 digit. And we group into 4s. Why? Because 16 is 2 to the power 4, so I group into 4s. Here 2 to the power 3, so I group into 3s. If I had a numbering system that is based 32, let's say 32 is 2 to the power 5, so I'll group into 5. And here's what I mean by grouping into 3s. We'll start from the right hand side and we'll take the first 3 binary numbers as my first octal number, and then we take the second 3 as my second number, third 3 as my third number, and here I have a 1 by itself. What does that mean? I'm not gonna take that 1. No, I'll take it and let's put it here, and I'll add zeros. Zeros are not gonna, on the left, they're not gonna make any difference. They don't change the result. So I grouped into 3s. And here's what's important here. What's this? This is 2 to the power 0, 2 to the power 1, 2 to the power 2, which is actually what? 1, 2, 4. And I take what? The 2 and 1, so this is 3. What about this? 1, 2, 4. This is 4. What about this? 1, 2, 4. So I'll take the 4 and I'll take the 1, and this is 5. What's this? 1, 2 and 4. So what do I do? Take the 1. This is 1. So this binary number equals this in octal. Now let's see, converting base 2, which is binary, base 2, 0 to 1, and I'm gonna keep adding that so it sticks in your mind. Base 8 is 0 to 7 to the power 3. I group into 3s. Consider each group as a single binary number after grouping into 3s. I consider those, and we did this. It's gonna give me what? 3, and here this is gonna give me 4. And here's an example. We took 0, 0, 0. What's this gonna be? 1, this, multiplied by 0, this is gonna give me what? 0. Then I have the 2 multiplied by the 0, which is this, equals 0. Then I have the 4 multiplied by the 0, which is this, and equals 0. And I add those 3, and this equals to 0. What if I had 1, 1, 1? This one is what? 1 multiplied by 1, which is 1. 1 multiplied by 2, which is 2. 1 multiplied by 4, which is 4. And I add, and this is gonna give me the largest octal number, which is 7. So what's this gonna be? 4. What's this gonna be? 5. And what's that one? It's 1. So this octal number equals this binary number. So example here, let's see, we have all that big number and we need to find the octal value for it. This is a binary. Sorry, I didn't put, but I should have put it this way. Always try, get used to put it this way. And now what will I do? Starting from the right hand side, I group into 3s. Why 3s? Because it's base 8, and I put a space between them. Make it look better and easier to group. so you don't confuse yourself, and please try to do it, or mark every number that you take into another number so you don't get mixed here at the end. Did I take the 1 or 0 or no? You'll be thinking. So what's this? We said 1, 2 and 4. Sorry, so this is 3. What's this? 1, 2 and 4, which is 7. What's this? 1, 2 and 4. This is 0 and 0, so I'm left with the 2. What's this? 2 and 4, and I have the 4 and 2, so this is 6. Here I have 1, here I have 5, here I have 0, here I have 1, 2, 4, so I'll have 4. This is 1, sorry, this is 1, so think of this as 1. So this is my octal number that equals what? Base 8 octal that equals this binary number. And here how it goes. And this is really important, guys, careful, please know it. Octal, though it's not in the book. Now how do we convert from what? Octal, which is base 8, to binary. We said each octal number is how many binary digits? 3. Why? Because I have from 0 to 7, because it's base 8. So I group what? Each number by itself, and I'll have 3 bits representing each one of those. This will have 3 bits, this will have 3 bits, and the 5 will have 3 bits, meaning a total of 9 bits. So here I'll put the 1, 2 and 4, my 3 bits. 1, 2, 4, my 3 bits, and 1, 2, 4, hopefully. Oh, oopsie doopsie, let's put the 2 here, and let's take this 2 as a 4. So what's the 3? 3 is 1, 1, 0. What's the 7? It's going to be 1, 1, 1. What's the 5? It's going to be 1, 0, 1. And this is my binary number. And let's see how they did it here. Group, take each one by itself. We put 1, 2, 4. And now, okay, this octal number equals this binary number. Now converting from base 8 to what? From octal to decimal. The easiest way is we do the our first step is going to be converting that decimal number to binary, which we took in chapter 2 until in lecture 2. So if you don't know it, go back to lecture 2 and know it, please. We convert from decimal to binary after I get the binary. You got the binary for the 10. Let's say for example I have the 11. I don't want to say 11. 19. 19 is a decimal number. I convert it to binary. And how do I convert it to binary? It's going to be 1, 2, 4, 8, 16. I'm not going to go to 32 because it's more than 19. So I have a 16, 0, 0, 18 and 19. This is going to be my binary number. base 2, sorry, it didn't take. Now if I got this binary number, how can I convert it to octal? I group into 3's. So those, I'm going to take those 3. Sorry, circle is better to do. And I'm going to take those 2, sorry. 2, 4, 1, 2, 4. What do I have now? 3. And here I have 1, 2, and the 4 is already what? 0. So this number in octal is what? Is 8. This is the binary, this is the decimal, this is the octal. Now if I want to convert from what? Base 8 to decimal. I got what? From 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 decimal base 10 to octal base 8, and now we're gonna do the invert from octal to decimal. Convert to binary. So if I had, let's say, 2, 5 and 7 as my oh no, I don't want it big, so let's leave it 2, 5. Let's leave it 2, 5 because I've got examples, but I want to explain those. In this is 2, not 7. Look at my 2. It looks like it's, I should have kept it 7. This is base 8. What do? We convert to binary. How do I convert it to binary? Each one of those is 3 digits, so I'm gonna have 6 digits. 2, 1, 2, 4, and 1, 2, 4. And what's the 5? 1, 0, 1. What's the 2? It's gonna be 0, 1, 0. So this is my binary number. How do I convert it to decimal? You know, we did what? 0, 1, 0, 1, 0, 1. Put 1, 2, 4, 8, and 16. And you know, we can't we can't use more than those numbers. Sorry about my handwriting. So 1, 2, and 4 for the first number. This equals what? 5. We're gonna add it, and this is 8 and 16. I have 16. I have a 1 only here. What's 16 plus 5 is 21. So this is in what? Base 10 decimal. This is in binary, and it's really good to know, guys. Please, converting base 10 to base 8, convert to binary as we took in lecture 2, convert from binary to base 8 as we took. Or we can do the division operation. Remember, also we took it in chapter 2, decimal to binary. We divide the decimal number by 2 and take the remainder. That's why I only have here the remainder, but it's going to be a division operation. And we're going to see, for example, if I have 198, what is it? Can I we're gonna now divide by 8 because I want the base 8, and I'll take the mod only, the remainder, meaning the remainder. So what's 198 divided by 8? 198 divided by 8. Oof. Why is it doing that? Oops. So here, I wrote it, 24. What's my remainder? 24 multiplied by 8. Let's see how much. 24 multiplied by 4 is 96. 96 and 96 is gonna be 180, 192. 192, and I have 198. So my remainder is what? 6. Now 24, 8 divided by 24, it's gonna be 3. Remainder is what? 0. Now 8 divided by 3, I can't. So what would I do? I'll put 0 here, and I'll take the 3, all of it. And remember, as we took previously, I go bottom up, meaning the number is read this way: 306 octal, not 603. Be careful, not 603. 6300. So now we finished lecture 3. It was short. Hopefully I'm gonna try to keep every lectures like this. I'm gonna post this with lecture 4 tonight. Thank you, guys. I still have till 7 ready, but I was busy all week working on other stuff. I'll tell you about it later. Thank you, guys. Study good. If you have any questions, please feel free to leave it on the comment section, and I'll answer as soon as possible.